Hello class, this video is about completing the square. So when we talk about completing the square, the first thing we need to know is what a perfect square is. Well, a perfect square is like a square number, like 4, 9, 16, 25. To get a perfect square, you multiply something by itself. It's the product of something and itself is a perfect square. Like here you can see a square with 3 on both sides. Well, what would the area of the square be? It would be length times width. 3 times 3 is 9. Or here, x times x makes a perfect square. The area of that square is x squared. And here I have x plus 2 on the side and x plus 2. Multiplying each box gives me the numbers on the inside, and x plus 2 times x plus 2 multiplies out using FOIL to give x squared plus 4x plus 4. And I'd like to show you that multiplying process. Alright, so I'm going to demonstrate multiplying with tiles using this last example right here, 2x minus 1 squared. Alright, to do that I have a tile here with an x on it. So here's x, 2x, and minus 1. Let's use those orange for positive numbers, and we'll use a pink 1 for negative 1. 2x minus 1. And we're going to multiply that by another 2x minus 1. Okay, so here I have 2x minus 1 across the top and 2x minus 1 here. Now we're going to multiply. So here I have x times x is x squared, and an x squared block goes there. X times x is again x squared. X times negative 1 is negative x. X times x is x squared. X times x, again x squared. X times negative 1, negative x. Negative 1 times x, negative x. Negative 1 times x is again negative x. And then negative 1 times negative 1, positive 1. So we need an orange square there. So the process of multiplying can be demonstrated with these algebra tiles. And I wanted to remind you of we have already done that, because we're going to use that today to see the process of completing the square. Because what shape does this make? It makes a square. So as we're doing this, it makes physically, what I want you to see is that it makes a square. Numerically, as you look at these numbers, you need to find the pattern. All right? When I multiply out x minus 3 squared times itself again, this is what you would get if you were to take the time to FOIL it out. How do these numbers relate back to the 3? If you were to have this 3, how could you get this 9 on the end? Okay, what would you do with the 3 to get to the 6? Okay, look at that pattern. Does that pattern hold here? This pattern that you see here is the same, and it's the same for all of these quadratics, all of these perfect squares. So let's talk about how you take something like this, okay, and that might not have a perfect square and make it into a perfect square. Completing the square forces the quadratic equation that you start with to become a perfect square. It forces it to be a square. So you're going to add something to it to make it become a square. Now, the reason we're doing this, why? We're doing this because it makes it easier to solve for x. Okay, once you've completed the square, it becomes easy to solve. And completing the square changes it from being in standard form to being in vertex form. And vertex form is better because then you can graph it easily. You can see what the vertex is in different aspects of the graph. But we haven't done vertex form yet. So far we're familiar with standard form. Standard form of an equation is ax squared plus bx plus c. Now when we complete the square in standard form, this a in front of the x squared here has to be 1. A must be 1. Now, to complete the square from this form, you're going to take whatever number the b is, okay, the coefficient of the x, and you're going to take half of that number and you're going to square it. So you're going to add half of b squared. You're going to add it, whatever b is, take half of it and then square it. And that is the magic thing that you need to remember for completing the square. So let's look at this. Here we have x squared plus 8, 8x, plus what to make a perfect square? Well, half of 8 is 4, and 4 squared is 16. So you need to add 16. You square it and you get 16. So now this is a perfect square. If you were to do your backwards foiling, if you were to factorize this, you would get a perfect square of x plus 4 and x plus 4. Because we got a 4 down here for half of the 8, this is x plus 4 squared. Now if you wanted to factorize this like we were doing previously, you can, but this is always true. It's always just half of the middle term. So now what would we need to add here to make this one a perfect square? Well, I have a minus 2, right? Well, half of negative 2 is negative 1. Okay, and so now we're going to square it. Well, negative 1 squared, negative 1 times negative 1 is positive 1. So we need to add a 1. Okay, now x squared minus 2x plus 1 is now a perfect square. We got a negative 1 for this, so this is x minus 1 squared. Okay, and this works with odd numbers as well. Here we have x squared plus 5x. What do we have to add to it to make it a perfect square? Well, half of 5 is, let's just say 5 over 2. Make a fraction out of it. 5 squared is 25, 2 squared is 4, so we need to add 25 over 4. Once we add this, this is now a perfect square. It is x plus 5 over 2 squared. And here we have a coefficient of negative 1 in front of the x. Half of negative 1 is 1/2, and 1/2 squared is 1/4. So we need to add 1/4 here. So now the perfect square is x minus 1/2 squared. So if the middle sign is a negative, then you have a negative inside here. And if the middle sign is a positive, then we have a positive. Okay, let's see if we can use algebra tiles here to help us solve this last example. Okay, so I have x squared plus 8x plus 12, and I've taken out the corresponding tiles. Here I have an x squared block, and I have 8 of these x's, and I should have 12. So now, what we're going to do is we're going to take the 8 x's from the middle here, the 8 x's, and we're going to divide them in half, and put half of them on one side of the x squared and half on the other. So, okay, so now I'm going to try to take my 1's here and fill them into this area here to make the rest of the square. Okay, and as you can see, I don't quite have enough 1's to finish off my square. How many more do I need? So, but here's the thing. I can't just add 4, it's an equation. In order to add 4, I also have to subtract 4. So, I'm going to get, as I add a positive 1, I also need to add a negative 1 to go with it so that they cancel out and keep my equation balanced at 0. So I'm going to add 1 and subtract 1 at the same time. Okay, so now I can use the positive 1's that I added and put them inside to complete my square. So when I took this equation and completed the square, what I ended up with was, let's see, this is x and then 4 more. So here is x plus 4 across the top. That's x. And then 1, 2, 3, 4 plus 4. And then coming down here, this side is also x. And then each of these is 1 long coming down. So I have 4 more here. This is x plus 4 times x plus 4. And then I have a minus 4 left over. Alright, so now I can solve from here by adding 4 to the other side, taking the square root of both sides, subtracting 4 to the other side for the final answer of x equals -2. Great!